Okay, we're going to be working Chapter 13, Section 5, Addition, Subtraction of Polynomials. So remember that we've already talked in Chapter 3 about this idea of a term. And the term is just the product of a number and one or more variables, and those variables can be raised to different powers. And the coefficient of that term is just the number that's sitting in front. So for example, on the term 2 times x, the coefficient is the number by itself, which is just 2. If we look at the term y, we realize that there is a 1 in front of that y, and so the coefficient is 1. On this term, negative 2/3 a times b, that number, negative 2/3, is our coefficient. For the term 6x squared y cubed, the number 6 is our coefficient. And if we just see a number by itself, like negative 5, then of course negative 5 would also be the coefficient. So those are terms that, or those are definitions we've already seen. Okay, a blank is a finite sum of terms. All right, so a polynomial is a finite sum of terms. No variable should be raised to negative powers, or no variable should appear in any denominator. So some examples of polynomials are, I don't know, let's say 3x squared plus 4x minus 5. So notice that this is a sum or difference. It doesn't matter if it's adding or subtracting. It's a sum or difference of multiple terms. So here we have one term, here's another term, here's another term. So we are just adding and subtracting terms together, and if we do that, we get what's called a polynomial. We have some conditions though. We have to make sure that the powers on our variables have to be positive, and they have to be nice whole numbers. So like for example here 2 is the power on x. That's a nice whole number and it's positive. On the x right here, that's really x to the first power. So that's 1. That's a nice positive number. Here's some things that would be examples of things that are not polynomials. If you wrote like 1 over x, let's say plus 5 times the square root of x. This would not be a polynomial, even though you have addition and subtraction, or addition between two terms. This right here, we learned from last section, that's really the same as x to the negative 1. And there you would say that that's a negative power, and we don't want that. And later on, we'll discover that this really means x raised to the 1/2, and again, this is a positive number, but it's not a nice whole number, it's a fraction. So that's an example of something that's not a polynomial. Now, anytime we are given a polynomial, we want to try and write them in what's called descending order. And that means you want to write it from the highest power of the variable down. So for this example, if we look, the highest power of x that I see is the 4th power. So we'd want to write that term first, negative 3x to the 4th. Okay, we're done with that. Now the next highest power I see is x cubed, so we're going to want to write that term down next. Minus 2/3 x cubed. Okay, done with that. The next highest power we see is x squared, so we go ahead and write that down, plus 7x squared. Then the next highest power we see is just this x right here, x to the first power. So we'll go ahead and write that term down now, minus x. We're done with that. And then now we have a number by itself, which is just plus 2. This is that polynomial written in descending order. Okay, now a monomial is a polynomial with one term. So we'll give examples here in a second. A binomial, bi meaning 2, is an example of a polynomial with 2 terms. And a trinomial, tri meaning 3, is a polynomial with 3 terms. So an example of a monomial, 4xy squared. That is a single term. We don't see any addition or subtraction. A binomial could be something like 5x squared plus y. That would be a binomial. There are 2 terms. And then a trinomial, something like, I don't know, x squared minus 3x minus 4. That's an example of a trinomial. We have 1, 2, 3 terms. Now, the degree of the term is the sum of the exponents for all the variables contained in the term. So let's take a look here. On this next example here, we have the term 2x, so x to the first power. the degree of that term would be the sum of all of the powers that we see. And we only see that power 1, so the degree of that's 1. Here on the next one, we have y squared. That's the only term, so we put 2. Here we have a to the first power, b to the first power. We ignore the coefficient completely. In fact, we were ignoring the coefficients here. But we have a to the first, b to the first. If we add that up, 1 plus 1 is 2. So the degree would be 2. Here we have x squared and x cubed, so we add those together, we get 5. And here we don't have any variables, so anytime you don't have any variables, we say the degree of the term is 0. All right. So, I'm sorry, did I say degree of the term? I think I said degree of the term is 0. Now, the degree of a polynomial, so what is the degree of a polynomial? Not of a term, but of an entire polynomial. It is the largest degree of all the terms. So let's look at this example here. Let's just write down what the degree of each term is. The degree of this one's 5, this one's 3, this one's 2, this one's 1, and this one is 0. So what is the degree of this polynomial? It's the highest number we see there, which is 5. Now, the term with the highest degree is called the leading term, and its coefficient is called the leading coefficient. So if we look at this example, this is what this group work assignment says. If we look at this example right here, what is the leading term? Well, the leading term is the one that has the highest power in it. So our leading term would be 4x to the 5th, and the leading coefficient would be the number in front. So that number 4 would be our leading coefficient. And the whole thing together is our leading term. All right. So in this, what we're going to do is we're going to look at these examples. We're going to classify them as either monomial, binomial, or trinomial, and then identify the coefficient and degree of the leading term. So for this first example, I have 3 terms, 1, 2, 3. So I have 3 terms, so it's a trinomial. Just going to put tri. The leading term is this right here because it has the highest power of z. So my coefficient is 13. And of course the leading term, well, let me put the leading term first. There's our leading term, and our leading coefficient is the number 13. Okay, for this right here, that's just a single number or a single term, so this is a monomial. And the leading term is just itself 6, and the leading coefficient is, again, just the number 6, so not much to do there. Okay, this one has 2 terms, so it's a binomial. And the leading term is negative 4x, and the leading coefficient is just the number. Okay, this one right here, we have a single term, multiplication between all of those. So since we have multiplication between all those, this is a monomial, single term. The leading term is itself, and then the leading coefficient is a number out front, 8/9. Okay, recall that terms are said to be like terms when they have exactly the same exponents raised to the same powers. So these are examples of like terms. 5x and 3x are the same, are like terms because they both have just a single x. The next one, these are like terms because they both have x squared. The next 2 are like terms because they both have xy cubed. And these are both like terms because they're just numbers by themselves. So these are examples of like terms. Now, where is this all leading us? It's leading us to adding polynomials together. So if we're given, we know what a polynomial is now. How do we add polynomials together? So if we know that polynomials are made up of terms, then to add the polynomials, all we do is combine like terms of the polynomials. So let's take a look at this first one. If we have these two added together, are they like terms? So do they both have a cubed? Yes. Do they both have b squared? Yes. Okay, so those are like terms, but how do we add them? Well, all you do to add like terms together is just add the coefficients So I'm going to do 9 plus 11, which is 20, and then I just put the variables. I don't do anything else to the variables, just leave them, a cubed, b squared. Okay, how about over here? We have 4 take away, minus 4x squared plus 7x minus 5, and then this plus 1, we could distribute a positive 1 through, which doesn't change anything. This is plus 6x squared minus 3x minus 2. Now, we have different terms, and some of them are like and some of them aren't. So let me highlight the like terms. These two are like terms because they both have x squared. These two are like terms because they both have just x. And these two are like terms because they both are just numbers by themselves. So to add them, we're going to combine these two together by just adding their coefficients. Negative 4 plus 6, that's 2, and then we just write down the variable. Here, when we add those together, 7 minus 3 is 4, so we go plus 4, and then we just write down the variable x. And then the last two we put together, it's negative 5 take away 2 is negative 7. So there is our simplified polynomial. Okay, opportunity here to do these problems. I'll give you a moment. Okay, here's what we're going to do. Rewrite this and distribute a 1 through here. So we get minus 11xy plus 4. Now look at our like terms. The only thing that we have that's like here is the 5xy minus 11xy, and then we can also put together, we can also put together the minus 1 plus 4. Otherwise, we can't do anything with that 8x cubed y squared out front. Just leave that alone. So to add these two together, we're going to do 5 and take away 11. That's negative 6xy. And then we put the minus 1 and the plus 4 together. That gives us plus 3. There we go. Okay, on the next one, we get 2/3 a squared minus 4/15 a plus 2 plus 7/3 a squared minus 1/15 a minus a half. Now I know the fractions are kind of not nice to look at, but it's the same principle. We're going to put those two together. They're like terms. They both have a squared. We're going to put minus 4/15a and minus 1/15a. And then we're going to put together the plus 2 and the minus a half. Let's go ahead and do that. So when I put these two together, I add their coefficients. So I need to do 2/3 plus 7/3, and that's going to give you 9/3, which is really 3. So that just turns out to be 3a squared. Then I put these two together. So I need to do negative 4/15 and then minus 1/15, same denominator. So we just go negative 4 take away 1 is negative 5/15. That gives me negative 1/3 if I reduce that fraction. So we get minus 1/3 and then just a. And then finally, put these two numbers together. I need to do 2 take away a half. So I do 2/1 minus 1/2. I need a common denominator. So I multiply top and bottom here by 2. So we get 4/2 minus 1/2 is 3/2. So we get plus 3/2. And there we go. Okay, now when it comes to subtracting polynomials, we're going to do the same thing, all right? We just need to remember that when you have a minus sign in front of parentheses, you distribute it like a negative 1 through the parentheses. So it changes the sign of everything. If it was positive, it now becomes negative. If it was negative, it becomes positive. This one here is positive, so it becomes negative. So that's what happens when you take a minus and pass it through. So let's see how that would work here. For this problem, we do 6x cubed plus 4x squared minus 2x minus 5. And now I'm going to take this negative 1 and distribute it through, changing the signs of everything there. Let's get minus 4x cubed, get minus 13x squared, minus x, and plus 2. So all the signs changed. Now I can collect like terms. So I've got x cubed there, those two can go together. X squared here, x squared here, I can put those two together. Minus 2x, minus x, put those two together. minus 5 plus 2. So if I put the yellows together, I should just get 6 take away 4, which is going to be 2x cubed. Put the blues together, I go 4 minus 13, that's minus 9x squared. Put the pinks together, minus 2, and then take away, this is really a 1, so minus 3x. And then minus 5 plus 2 gives me negative 3. So there we go. Okay, I'll let you do this first one, but I'm going to do this one. Subtract that from that. So you have to be real careful here. It's like me saying subtract 4 from 10. That doesn't mean you write down 4 take away 10. That's not what this means. It means you're going to take 10, you're going to subtract from it 4. So when we read this, we really want to write down 2h plus 12, take away from that negative h plus 17. And now to do this subtraction, we have to look at this as a negative 1, and we have to distribute it through. So we'll have 2h plus 12 plus 8h minus 17. Now we have like terms, 2h and 8h, and we also have 12 take away 17. So that should give us 10h, and then 12 take away 17 is negative 5, so 10h minus 5. Okay, that's it for adding and subtracting polynomials.